to the lesson on powers and exponents basics. So what is an exponent? An exponent is the number of times a number is multiplied by itself. And by the way, the words powers and exponents are used interchangeably. So let's say that you have 5 squared. And by the way, this is also read as 5 to the second power. So this 5 right here is your base. And this 2 is your exponent or power. So what I mean by a number of times a number is multiplied by itself is that this base will be multiplied twice. So 5 times 5. So how do I know to multiply this 5 twice? Well, that's dependent upon the number that's on your exponent, which is 2. All right, and we know that 5 times 5 is 25. All right, let's say that you have 5 cubed. Okay, you know 5 is your base, 3 is your exponent, so you're going to multiply 3 times 5 times 5 times 5, which is equal to 125. Okay, so this is read as 5 cubed, or another way of reading that is 5 to the third power. Now, powers of 10, let's talk about powers of 10. So if you have 10 squared, 10 cubed, or even 10 fourth, or 10 to the fourth power, the number of zeros is based on your exponent, right? So we have a total of 2 zeros. Okay, so this is actually written as 10 times 10, which is 100, right? So 10 times 10 equals 100. So notice I have 2 zeros, and that's dependent upon the exponent here. So the same thing with 10 cubed, 10 times 10 times 10, which is the same as saying 1,000, and then 10 to the fourth power, which is 10 times 10 times 10 times 10, which is equal to 10,000. Okay, so just look at the number of zeros and you'll know. So you don't even have to expand all of this out as long as you understand what's going on. All right, so let's go ahead and move on. So I'm going to go ahead and talk about multiplying powers of 10. So when multiplying by powers of 10, we're simply moving the decimal point, the amount of places that's given by the exponent. For example, if you're given a number like 0.45, I'm just going to use a repeating decimal here, 45, and that's multiplied by 10 squared, all you're doing is moving your decimal point 2 places to the right. Okay, so just go ahead and move this 1, 2. Get rid of everything else here and just rewrite it. So your new answer is 45.45. Okay. All right, so let's talk about dividing by powers of 10. So when dividing by powers of 10, we're going to move the decimal point, the amount of spaces that's represented by the exponent. So let's say that you're given 1.6 divided by 10 to the negative third power. Okay, so what you're going to do here is, since your exponent is negative, you're going to move the decimal point 3 places to the left this time instead of to the right. Okay, so 1, 2, 3. Your decimal point is here. You fill in the rest with zeros. So you have 0 point. So by the way, this is a 0 in the whole number's position. All right, so you have a total of 3 zeros. That's how I like to look at this too. So the third 0 will be in your whole number's position. So that's your new number, 16 10,000ths. Okay, so let's go ahead and move on and talk about the product rule for exponents. Okay, so when multiplying exponential expressions with the same base, you keep the base and add the exponents. For example, if you're given 4 squared times 4 cubed, you have the same base, okay, which is 4. So since you have the base of 4, you're going to keep the base and add the exponents together. So 2 plus 3 is 5. So basically what you're doing, you're just counting. So if I rewrite this in its expanded form, it looks like this. So 4 squared is 4 times 4 times 4 times 4 times 4. All right, and as you can see, we have a total of 4 fives. So it's representative of 4 to the 5th power. So that's why this works. Okay, so let's say that you're given 2 cubed times 2 to the 6th power. What's your guess for this answer? So you can pause the video if you need to. So we have the bases that are the same, which is 2. We keep the base and we add the exponents, which is 9, 2 to the 9th power. Okay, so let's go ahead and move on and talk about quotient rule for exponents. So when dividing exponential expressions with the same base, we keep the base and subtract the exponents, right? So just the opposite of multiplying exponents. So here, if you're given 8 to the 4th power divided by 8 squared, you're simply going to keep the base of 8 and subtract the exponent. So 4 minus 2 is 2. So your answer here is 8 squared. Okay, so let me actually say how this works. So you're going to take the 4 8s on the top and multiply. So 8 times 8 times 8 times 8. And that's divided by 8 squared, which is the same as saying 8 times 8. So all you're going to do is go ahead and you're going to cancel out ones. So what I mean is that 8 divided by 8 we know is 1. 8 divided by 8 is 1. Okay, so we don't need these. So we're left with 2 extra 8s. Okay, so that's why this works. So if you notice, there's 2 extra 8s in the numerator than what's contained in the denominator. All right, so just recall that these cancel out as 1 because 1 times 1 times 8 times 8. It's like that, and 1 times 1 is just 1, okay? All right, so let me go ahead and cover just a couple more things. Okay, so let's say that you have -4 enclosed inside of parentheses raised to the 2nd power. And let's say you have -4 squared without parentheses. So I actually had students say that you have the answers that are both the same, but the reality is that they're not. So let's take a look at -4. So this base of -4 surrounded by parentheses, we're going to take this whole entire base and raise it to the 2nd power. Okay, so when you do that, you're multiplying -4 times -4. And by the way, parentheses also denote multiplication. So -4 times -4 is 16. So now let's take a look at -4 squared without parentheses. So the base that's tied to your exponent is 4, not the negative. All right, so what you're going to do is multiply 4 times 4, right? So 4 times 4 equals 16. Then you're going to take the opposite of whatever answer you get and attach your negative sign. Okay, so as you can see, 16 and -16 are 2 different answers. Okay, so I just wanted you to be aware of that. So just a couple more examples. So let's say that you have 3 squared raised to the 2nd power. So what you're doing here is just taking 2 copies of 3 squared and multiplying. So we have 3 squared times 3 squared. So as you can see, we have bases that are both the same, 3. We're going to add the exponents, and we have 3 to the 4th power. Now, another way you can look at this is written out in expanded form. So 3 times 3 times 3 times 3. All right, we have a total of 4 threes. So what you're doing is actually multiplying power by power or exponent to exponent. So your answer is actually 3 raised to the 4th power. All right, and one final example. So let's say that you have 2 times 3 in parentheses raised to the 2nd power, and same thing, 2 times 3 raised to the 2nd power. So there's actually 2 different ways of looking at this. You can take and multiply the factors, 2 times 3, which is 6, and square it, which gives you 36, because 6 times 6 is 36. Or you can take each individual factor and square it. So 2 squared times 3 squared, right? So when you expand it, it's 2 times 2 times 3 times 3. 2 times 2 is 4, times 3 times 3 is 9, which is equal to 36. So that's all we have. Thanks for watching, and I hope to see you in the next lesson.